Hello friends, we now discuss three-dimensional geometry. It is the second unit of this our session, that is three-dimensional geometry. Three-dimensional geometry contains 3 points most important, that is the direction angle, direction cosine and direction ratios of the line. Firstly, direction angles of the line that are denoted by alpha, beta and gamma. Note that alpha, beta, gamma are not exceed the pi. Pi means 180 degree. These values of the alpha, beta, gamma are not more than 180 degree. They are must be always less than that. This is the most important thing related to the alpha, beta and gamma. Direction cosine of the line. Direction cosines are in short denoted as DCS or LMN. L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma, and relation between them is that L square plus M square plus N square is equal to 1. L square plus M square plus N square is equal to 1, which is one of the most important useful result in this one. That is the cos square alpha plus cos square beta plus cos square gamma is equal to 1. Now, direction ratios of the line. In short, we write this sometimes as the just DRS. DRS are denoted by ABC, that direction ratios are scalar multiples of the direction cosines. That is scalar multiple of M and N. They are denoted by ABC. Next, relation between direction ratios and direction cosines. Direction ratios means ABC. Direction cosines means L, M and N. Our target is to find L. Formula related to that is there. L is equal to plus or minus A upon root plus M is equal to plus or minus B upon root and N is equal to plus or minus C upon root, where root is nothing but root of A square plus B square plus root of A square plus B square plus C square. Now, this is the relation between DCS and DRS. Our target is to find DCS and DRS of the line, and some another tool related to this one is that DRS of the line through the 2 points x1, y1, z1 and x2, y2, z2. That is, a line passes through the first and second point. 2 points of the line are given here, and that 2 points are, firstly we write the x1, y1, z1 and second point is that x2, y2, z2. Then find the DRS by using formula A is equal to x2 minus x1, B is equal to y2 minus y1, C is equal to z2 minus z1. Now, last part of this unit, this unit is the very short unit but basic one. That part is that DRS or DCS of perpendicular line to the given two lines. When a single line perpendicular to the two given lines, then the DRS of them given by, firstly we consider DRS of first line as the A1, B1, C1, DRS of the second line as the A2, B2, C2, and DRS of the perpendicular line is the ABC. Then we use the formula is like this: A upon determinant of B upon determinant of C upon determinant. Remember that when we choose A, then take the determinant as the B1, B2, C1, C2 and is equal to B upon, then copy paste C1 by C1, C2 again, that is the second column, and B is present, therefore remaining is that A1, A2. Now copy paste again A1, A2 and C is present, therefore take B1, B2. It is one of this shortcut technique to remember this one. Now, angle between two lines. Angle between two lines. Cos of theta is equal to A1, A2 plus B1, B2 plus C1, C2 upon root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. This is the formula related to the angle between two lines. This is the most important formula. We use, this is the output of the dot product also. This A1, B1 and C1 are the DRS of first line, A2, B2, C2 are the DRS of second line. Now we discuss examples related to this one. Before this, we recap again theory related to this three-dimensional geometry, which is based on three pillars: direction angle, direction cosines, direction ratios, alpha, beta, gamma, LMN and ABC. Relation between LMN and N is L square plus M square plus N square is equal to 1. Then we discuss relation between DCS and DRS, that is we find the values of L, M, N using ABC. The formula related to the DRS for the 2 points of the line, that is the DRS of line is given by A is equal to x2 minus x1, B is equal to y2 minus y1, C is equal to z2 minus z1, and next point is that our target is to find the DRS of perpendicular lines. DRS of perpendicular lines means first line, second line given, and consider the DRS of perpendicular line ABC. Then we find the simplified formula here: A upon determinant, B upon determinant, C upon determinant, B1, B2, C1, C2, and A is present here, C1, C2 copy pasted here. Similarly, B is present, A is A1, A2 here. Similarly, A1, A2 copy paste here, and C present, therefore B1, B2 for the shortcut technique, and angle between the two lines is given here with the help of the DRS A1, B1, C1 and A2, B2, C2. Okay. Next, example number 1 related to this unit. Example number 1 says that alpha, beta, gamma are direction angles. Then our target is to find cos 2 alpha, cos 2 beta and cos 2 gamma. That is, options are like this: -1, 0, 1 and 2. Our target is to solve this question with the minimum time. Related to this, firstly we concentrate on the 2 alpha, that is cos 2 alpha. There is no any formula related to the 3D related to the cos 2 alpha. Therefore, we convert cos 2 alpha is equal to 2 cos square alpha minus 1, and when we find the output of them like this: cos 2 alpha plus cos 2 beta is equal plus cos 2 gamma is equal to cos 2 cos square alpha minus 1, 2 cos square beta minus 1 and 2 cos square gamma minus 1. Take 2 common. Terms of the cosines are present in the bracket. -1 minus 1 minus 1 becomes -3. 2 into 1 and -3, that is the output is the -1, and first option is the correct solution of this one. Example number 2. Check that. The direction cosine of the line which lies in ZOX plane and makes angle 30 degree with the OZ are. Options are given. Firstly, concentrate on the question: direction cosine of line which lies in the ZOX plane. ZOX. This line is present in the ZOX plane, therefore that line is must be perpendicular to the, that line gives us that beta is equal to 90 degree, therefore alpha is already given, alpha is not available, but angle with the OZ means positive Z axis, that is the 30 degree, therefore gamma is 30, beta is 90, alpha is unknown here. Now cos square alpha is plus cos square beta plus cos square gamma equal to 1. Alpha as it is, beta 90, gamma 30, therefore output like this: cos square alpha plus 0 plus root 3 by 2 square is equal to 1. Cos square alpha is equal to 1 minus 3 by 4, output is that cos square alpha is the 1 by 4. Now cos alpha is equal to plus or minus 2, plus or minus 2. Now L is equal to plus or minus 2, M is equal to 0, already find here, N is equal to cos 30, that is root 3 by 2. Check the options for the minus, plus or minus half, 0 and root 3 by 2, which is present in the option D, and therefore D is correct option. Okay. Now next, Okay. Next question. Question is, now we discuss example number 3. Example number 3 is that if a line is equally inclined to the coordinate axis, then each direction angle is of measure. Option is like this: sine inverse of root 3. Option B is the cos inverse of root 3. C cosec inverse of the root 3. D sec inverse of root 3. Here remember that the line is equally inclined, therefore alpha, beta, gamma are same. Therefore we write the alpha equal to beta equal to gamma, and therefore cos square alpha plus cos square alpha plus cos square alpha equal to 1. This gives us that 3 cos square alpha is equal to 1, and cos alpha gives us that plus or minus 1 upon root 3. Therefore output alpha is equal to cos inverse of plus or minus 1 upon root 3. But this option is not available in the given 4 options. Therefore we go to the trigonometry. Sec inverse of the x is nothing but the cos inverse of 1 by x. By applying that one, we obtain alpha equal to sec inverse of plus or minus root 3, and out of them sec inverse of root 3 is available in the option D, and that is the solution of this question. Okay. Example number 4 is that the direction cosine of line passing through first point 2 3 minus 1 and second point minus 3 minus 4 2, and options are like this. A option says that minus 5 upon root 83, minus 7 upon root 83, 3 upon root 83, and second B option is that 5 upon root 83, 7 upon root 83, and 3 upon root 83. Third option is the minus 7 upon root 83, 3 upon root 83, minus 5 upon root 83, and last option is minus 5 minus 7 3. Our target is to find DCS, and DCS are always fractions. Therefore minus 5 minus 7 3, it is not possible. Before that we find the direction ratios of the line related to the 2 3 minus 1 and minus 3 minus 4 2, that are firstly value of the A is the x2 minus x1, it is the 5 or minus 5, B y2 minus y1, it is a 7 or minus 7, and C is nothing but the minus 3 or 3. Therefore a root of a square plus b square plus c square is given by 5 square, 7 square and 3 square, that is the root of 83. Now direction cosines means our target is to find value of LMN. Therefore L is the minus 5 upon root 83, M is the minus 7 upon root 83, and N is equal to 3 upon root 83, which is present in the option A. Therefore option A is the correct solution. Now we discuss example number 5. Read carefully. If P is the point, that point is the 3 minus 6 10, and PQ is nothing but the root 17. Also DCS of PQ are DCS of PQ given like this: minus 2 by root 17, 3 by root 17 and minus 2 by root 17. Then the coordinate of Q is our target is in this question. Okay, options are like this: 5, 12, minus 9. B option says that 1 minus 3, 8. C option is that minus 9, 5 and 12. And last option is minus 2, 3, minus 2. Okay. We come at the point P. P point is the 3 minus 6, 10, and consider Q point as the x2, y2, z2. Therefore PQ bar is given by x2 minus 3, y plus 6, z2 minus 10. Therefore this is nothing, these three values are nothing but the DRS of the PQ bar, that is ABC. But ABC is already given, that is ABC, this DCS, and through this DCS we can write the DRS as just numerators minus 2, 3, minus 2. Okay. Therefore by simplification x2 minus 3 is equal to minus 2, y2 plus 6 is equal to 3, and z2 minus 10 is equal to minus 2. This gives us that x2 is the 1, y2 is a minus 3, y2 is a minus 3, z2 is a minus 8, which is present here. Okay. Check the options. Out of them, B option is the correct option of this question. Answer of this one is the option B. Now we discuss example number 6. Okay. Example number 6. Read question carefully. Firstly, given that if line L is perpendicular to L1 and line L is perpendicular to L2, the DRS of the L1 and L2 are given like this: 1 1 2 and 2 0 minus 1 respectively, then DRS of the line L are. Very simple question. This is related to the perpendicular line. Firstly, that A options are like this: minus 1 minus 5 minus 2, B minus 1 5 2, and C 1 minus 5 2, and D option is that 1 minus 5 minus 2. Okay. L1 line and L2 line must be perpendicular to the line L. Therefore, we firstly write A1 B1 C1 be the DRS of the L1, that are 1 1 2. DRS of the L2 are A2 B2 C2, that are 2 0 minus 1. Now just use the Cramer's rule formula, that is the A upon determinant, B upon and C upon, that is A upon B1 B2 C1 C2 means 1 0 2 minus 1. Okay. You copy paste 2 minus 1 again, and B is present, use first column, that is 1 2. Okay. Now 1 2 is first column of the last quantity and C is present, therefore you just skip the last coordinates and take the y coordinates, that is 1 0 in the second column. B, now A upon minus 1, it is the determinant simplification, B upon 4 plus 1 and C upon 0 minus 2. Therefore, A is nothing but minus 1, B is 5, C is minus 2, but this option is not available. But direction ratios are scalar multiples, therefore they are infinite. Therefore, we multiply ABC with the minus 1, then we obtain 1 minus 5 2, and which is available in the option C. Therefore, option C is the solution of this example number 6.